Hello everyone, my name is Jiahao Li. Today I want to introduce you guys about using bottleneck heuristic to solve hybrid flowshop scheduling problem. This presentation is mainly based on one paper by National Taiwan University of Science and Technology. First of all, let's do a quick review. Based on what we learned before, bottleneck heuristic is a procedure intended to minimize the time that it takes to do the work in a job shop. And flowshop scheduling is a special case of job shop scheduling where there is strict order of all operations to be performed on all jobs. Therefore, hybrid flowshop is actually one of the special cases which a set of jobs processed in a series of stages. The picture on this slide shows one example of hybrid flowshops. In a hybrid flowshop problem, machines are arranged into k stages in series. At each stage, there are identical parallel machines in at least one stage. Job J has to be processed on any one machine at each stage, and the machine can process only one job at a time. Preemption is not allowed, and there is unlimited intermediate storage between two successive stages. The scheduling problem is to choose a machine at each stage for each job and determine the sequence of jobs on each machine, so as to minimize the make span or maximize the completion time. Like other flowshop problems, HFS is to find a schedule which optimizes a given objective function. In this formulation, the objective is to minimize the make span Cmax. Constraint number 1 and number 2 are used to define the make span. Constraint number 3 ensures that each job is processed exactly by one machine at each stage. Constraint number 4 ensures that each job can be processed at current stage only after it has been completed at preceding stage. Constraint number 4 and number 5 together require that each machine can process only one job at a time, and at the startup time of the current job must be greater than the finishing time of the preceding job. All the decision variables are integers, so the model is an integer programming formulation. To solve this kind of problems using bottleneck heuristic, we need 3 steps. Step 1 is to identify the bottleneck stage. First, we calculate the flow ratio between the total processing time and number of available machines at each stage, and select a stage with maximum flow ratio. Then, calculate the total processing time for each job at every stage before the bottleneck stage and denote by Rj. After that, we find out the difference between total flow ratio at every stage with the total processing time at every stage and denote by Dj. Step 2 is to sequence the bottleneck stage. For Rj, if there is more than one job with the same Rj, then rank them in increasing order of Dj. Break ties by selecting the one with smaller processing time. Step 3 is to sequence the non-bottleneck stage. We need to find the stage before the bottleneck stage and the stage after bottleneck stage. Let's see one example problem. In this HFS problem with 4 jobs and 3 stages, the first and third stage consist of one machine, and the second stage consists of 2 identical machines in parallel. The processing time are given. In the first step, we can apply the procedure to calculate the flow ratio. For each stage, stage 1 is 16, stage 2 is 26, and stage 3 is 16. Therefore, the second stage is the bottleneck stage. After that, we calculate Rj Dj at the bottleneck stage, which is Rj 5, 2, 3, 6, Dj 52, 55, 56, 53. Now schedule the jobs according to Rj Dj and processing time at the bottleneck stage and obtain the results as shown in this slide. Also, number 3 and number 1 in this M1 column shows the sequence of job 1 and job 2. Next, the job at the first stage and third stage are used the same approach to find out RJ, DJ, and processing time, and we can schedule them in increasing order at each stage. After that, when we obtain the job sequence at the first and second stage, we calculate the completion time for each job until the bottleneck stage. The jobs at the third stage are scheduled as soon as they are completed by second stage. The final sequence is shown in this slide. Hybrid flow shops are common manufacturing environments in many industries, such as the glass, steel, and paper industries. Examples are found in production of concrete and manufacturing of photographic film and others. It also happens in non-manufacturing areas like civil engineering, internet service architectures, and a container handling system. That's all my presentation today. Thank you for listening.